This is taketomba, a really famous Japanese toy. On Earth, if we rotate the taketomba, we can expect that it will go up to the sky and then fall down a little while later. This is because when we rotate the taketomba, this rotation gives taketomba a lift. And when the air drag slows down this rotation speed, the lift decreases, and finally, gravity will pull the taketomba back to Earth. In this experiment, we would like to observe the motion of taketomba in International Space Station. In our extinction, we can think that we could guess the taketomba will go one direction until it collides with the wall of International Space Station. However, in space, another effect might change the motion of taketomba, the Dish-Honeybekel effect. Astronauts have rotated the T-handle to show this effect. One can see that the T-handle keeps flipping like this. And when it goes back to here, like this. Yeah, the T-handle will keep flipping like this during rotating concerning this axis. Taketomba and T-handle had the same shape. So we can derive that playing taketomba in International Space Station might also undergo this Honeybekel effect. Since comparing to T-handle, the wings of taketomba would create more lift. An interesting question appears. How will lift and this Honeybekel effect interact with each other? In this experiment, we will make two observations. The first is the direction of the flip, and the second is how long it stays in both the orientations. So we will make a few definitions here. So now, if the taketomba travels in this way, we first define this orientation as the same orientation. And this, recall that our taketomba traveling this way is the opposite direction. For the direction of the flip, to show this, we will color the wing of taketomba, like this example. This side is white, this side is blue side, white side, to have a better observation. For the duration stays in both orientations, we should like to observe how long the taketomba could stay in one orientation. So maybe in this orientation it stays 3 seconds, and in this orientation it stays 5 seconds. Since taketomba would travel in one direction with initial acceleration, we are interested in that if this would affect the stability of taketomba in different orientations. In our prediction, we suggest that it would just look like T-handle in International Space Station and that it would flip during rotation. However, as lift exists, this force may cause taketomba more unable to flip, making it more stable in one direction. Since one taketomba is hard to tell with the effects of lift in this experiment, we will send multiple taketomba with different angles of attack to generate different lifts. And for the direction of the flip, as a T-handle in International Space Station, we suggest that the flip direction would be same starting from both orientations, just as the spin direction of the taketomba. For this example, if taketomba spins like this, and then it will become unstable and then flip back, like this. Sorry. Yeah, it should be like this. And when it rotates back, it rotates like this. So this is our prediction, just as the T-handle example that has implemented in International Space Station a few years before. To understand the Dish-Honeybekel effect more, we would also change several parameters to see their effect on the final result. These parameters include the rod length, the radius of the wing, and the number of wings. Also, we have mentioned the angle of attack of wings before for different lifts. We could have multiple taketomba by using 3D printings or other assembling techniques. Since all these components can be disassembled like this, we 3D printed this a few days before, it would be really easy to carry on ISSs. You just have to carry this, and maybe multiple of them. And when you go to International Station, you just put them back like this, and you can start the experiment. We hope that this experiment could help us understand more about this Honeybekel effect on Taketomba, and showed that simple toys could bring some great scientific meanings. Thank you.